All right, we're coming to you live from an air base. You can probably hear the jets in the background. This is weird today, but hi Ash, wherever you are, Cape Canaveral. So here we go, day 3 of trig. We're gonna do law of and bowls. Yep, bowlsy. We're gonna learn about law of sines today. Calculate some areas. Let's get going. Here's a little snippet from the book you can take a look at of where you can use law of sines to find the area. Let's take a closer look at an example ourselves. Here is the area formulas, and you can kind of, we'll go back to this after you see us do an example. And so let's jump right in with an example. If you want to find the area of a triangle, you need to have the base and the height. Good, and it's 1/2 times base times height. So, but in this case, we don't have a right triangle. We don't know the height. So we have to calculate the height. So how can I calculate the height of this triangle? So katoa, good. So I'm going to draw in a perpendicular line from the base to the vertice above it, and that would be representative of the height. So we'll call that height, let's just call it x. So the height is going to be x. So how could I find x here? So katoa, right? Because ultimately what I want to do is I want to calculate the area of this triangle, which is 1/2 of the base times the height. And the way that I drew it in there is that the base would be 5, correct? So the base I know is 5, and I need to know the height, but I don't know the height, but I can figure the height out using so katoa. So let's see, how do we find the height? X is equal to, well, I don't want to put that yet. Let's say the sine of 40 degrees. Sine of 40 is equal to the opposite, which is x over the hypotenuse, which hypotenuse would be that side right there. The opposite would be the x side right there, so x over 3. So then, no, x over 3. Because see, here's a triangle that I'm doing right here. See that one? Okay. So now x is equal to 3 times the sine of 40. Whoops, right, that's a little crusty. 3 sine 40. All right, and so that's how we get the height, is in terms of using a sine ratio. So in this case, the height is 3 times the sine of 40. And so now, I didn't have a right triangle, but I created and discovered or calculated the height using SOHCAHTOA. So now the area is going to be 1/2 times the base, which would be 5 times 3 times the sine of 40 degrees. Okay, so what did I end up using there? I ended up using the 5, didn't I? In the formula. I ended up using the 3 in the formula, didn't I? And then I ended up using the angle, the sine of the angle in the formula, didn't I? And I took 1/2 times all that. And so this scenario, if I go back to the formula page, will work. Whoops. This scenario will work what are you talking about? Pause. This formula will work no matter what angle you start at. So if I used like angle A, right, then I would be the sine of angle A times the C and times the B times 1/2, right? And that's how I get this one up here. If I were going to use the angle B, then I would take the sine of B times the two sides at that angle is made up of A and C times 1/2. That's how I get that one there, right? So on and so forth. If I used angle C, then I would take sine of C times those two adjacent sides that make up that angle, A and B, and that's how I get this one there. So that's true for no matter what angle you start at. So that's kind of neat, right, Jades? All right, so now we get over to here and we look at the area. The area of the triangle should be the same no matter what angle you start at, right? So then let's say, all right, well then all those are equal. So if I start with angle A, that should be no matter what equal to if I use angle B, and that should be equal to if I use angle C, and so those all should be equal. And then what we can do is do some mathematical karate here, and we can go ahead and um, simplify all those expressions. We can multiply each one by 2, and that gets rid of all the halves, right? And then we can divide each expression by A, B, C, and that's going to leave us with this down here, which you know as the law of sines. And so that's why in any triangle, the sine of the angle over its opposite side is equal to the sine of any other angle over its opposite side. And so lo and behold, you have a law of sines formula that you can use to find missing sides and angles when the triangle might not be a right triangle. So again, this stuff is just, it's not for right triangles only, it's for any triangle. Okay, so let's put it to use here. Here we have, let's see, was I missing a problem? I think I skipped a problem too, didn't I? I did this earlier. There was a problem down here that I didn't recognize. Timeout. All right, so we did skip a problem. And you were saying, I feel like there's a height, way we could find the height without using SOHCAHTOA. It was probably just drawn into the problem. Sometimes like when you're doing those problems and you're doing area problems in geometry, the height is drawn in for you as like a side. But if it's not drawn in, then you have to use SOHCAHTOA to find that height. You can't because it's not a right triangle. You can't use Pythagorean theorem. First of all, this drawing is not very good. Okay, this is a good point. So, and some people earlier were thinking that this drawing was, you could, like you just said, you could divide 7 in half, because if you drop that down, it's exactly in half. But I don't think this drawing is accurate, right? This angle is supposed to be 85 right here. See what I mean? This angle says it's 60, but it's closer to 90, isn't it? So you got to be careful to make like inferences on things because of the way the triangle looks. You got to pay attention to what it's saying. So I don't think that, you know, if you drop a line straight down from here, that it's going to be halfway. If I drew this better, this would probably be 60, would probably be more like that, and then this one is 85 would be more like that. See, and so if this was like truly like 60 and this was 85 and this was over here at 35 and you dropped it down, see what happens here? So the picture is misleading. So you have to be careful on that. I know I flipped it around, but same kind of deal. So anyhow, let's do SOHCAHTOA, and then we would find our height. So then our height again is going to be the sine of 85 degrees over x is equal to, or sorry, I'm jumping the gun a little bit. Sine of 85 degrees is equal to x over 6. So then x is equal to 6 times the sine of 85. And like, you know, I know there's a formula for this on the other page, but I mean, unless you have a formula sheet, which sometimes you do on some of the tests, but you'll probably forget it. So now this is the height. So now that's that part, right? Whoa, whoa. So that's that part. So now I take 1/2 times 7 times that. This is the base of the triangle. It's 7, right? No, the formula for the area of a triangle is 1/2 times the base times the height, right? And so, do you agree that this is the height of the triangle? If this is the base? Yep. Yeah. times 2 and divide by half, or divide by 2 and times half, or same. You can multiply in any order you want. So you could take 1/2 times 6 times sine of 85. I mean, you're essentially multiplying what? 1/2 times 7. 1/2 times 7 times 6 times the sine of 85. You're multiplying 4 things together, right? So like the 4 things you're multiplying are sine of 85, 6, 7, and a half. And you can do any order you want. Because I use this triangle right here. And so there's my x, there's my 6, right? Okay. What if they didn't give you the 6? Then you're not going to be able to do it. Unless they gave you this side. Right? So that's finding area. So sometimes you have to use SOHCAHTOA to find the height to find the area. Okay, let's cruise through. Now we talked about where the law of sines comes from. You have to be careful with the old side-side angle. Spelt backwards, but you have to be careful on that one because side-side angle does not guarantee one unique triangle. So I'll talk about that in a minute. But let's go ahead and put the law of sines to use. So now the question is, solve each triangle, round to the nearest tenth. So we want to find all of the missing values and in for the angles and the sides. So the angle isn't too bad because you should know that all the triangle angles add up to 180. So this one right here is 105. Okay. Now the law of sines states that any sine of any angle over its opposite side should equal the sine of any other angle over its opposite side. So in this case, now I can use the sine of 39 degrees divided by r is equal to the sine of 105 divided by 10. And then you have your missing, you have one missing side. Okay, so the sine of any angle over its opposite side, color code these for you, should be equal to the sine of any of the angles over its particular opposite side. But why sine? Because we just went through the whole, remember, we just did this whole deal. So if we go back, when you set this up and you're calculating areas, you're always using the opposite, woohoo, over the hypotenuse. And so it just happens to be sine. That's what works. So then you end up with the law of sines, and so here we are using it. So then if we use cross products to solve for r, say we have r times the sine of 105 is equal to 10 times the sine of 39. Divide both sides by the sine of 105, and you get r is equal to 10 times the sine of 39 degrees all over the sine of 105 degrees. Which in your calculator, if you round to the nearest tenth, Michaela, is going to be whatever. Michaela, she's a student that busted me on rounding to the nearest tenth. I wasn't following the directions. Was I, Dylan?
No, you were not. She made sure you knew about it.
Yep, she did. She did a good job. Divide by sine of 105. I get 6.5. Ka-chow. Okay, that's law of sines. How would you find Q? Same way, you just pick another one. Sine of 36 over Q. Yep. I'll just set this one up. Sine of 36 over Q is equal to the sine of 105 over 10. You could use the blue ones too, sine of 39 over 6.5, but that would be using a rounded one, a rounded value. And when you use something that's been rounded, it's less accurate. So I just stay away from that if possible. So I use a sine of, wait, what am I doing now? I'm talking to you and I wasn't paying attention. Sine of 105. So I would use a sine of 105 over 10 just because 10 is not a rounded value. 6.5 has been rounded, so it's not going to be as accurate. So then you get what you get and you don't throw a fit on that one. Make sure your calculator's in degree mode. Okay, same thing. So Q would be equal to, if I just jump straight to the answer there, Q would equal 10 sine 36 divided by sine of 105. But we're getting kind of long on time here, so I'm going to keep cruising. Okay, any questions? 6.1, good. All right, next question, we have an ambiguous case. So this is the scenario when you are given an angle and a side and a side. And so in geometry, there was no angle side-side postulate, right? Because it says a bad word, so it can't be a postulate. No, that's not why. I'll show you why though. Here, I'm going to go to the next page. I'll show you why. If you have angle side-side, here's what might happen. I'm going to take a nail and I'm going to put a nail in here. Ready? Okay, and then I'm going to swing this side. I'm going to swing this side with the single congruent slash on over like a watch hand, and it's going to be over here now. See? And so what happens is I have two triangles. I'll highlight this one. I have the yellow triangle that has the same angle side-side in common, and I also have the green triangle that has the same exact angle side-side. All right, so now when I'm using angle side-side and I use law of sines and I calculate a value for this angle right here, let's say this angle might be 50 degrees, okay? So you'd solve the problem, you're trying to find this angle, x, and you found it to be 50 degrees, and you're like thinking, okay, well, it's angle side-side, I gotta be careful, is that right? And that, in fact, may or may not be right. It might be another angle. So let's talk about this. What would this angle right here be? Also 50 because it's an isosceles triangle, and so the two congruent sides gives you the base angle theorem. The base angle theorem says those both are 50. So if those are 50, then what's this one right here? 130 because it's a linear pair. They're supplementary. So I guess what's happening here is if you use angle side-side, you got to be careful because the answer might be the answer that's given to you, or it might be the supplement of that angle. Because angle side-side, there's not one triangle that's guaranteed. There might be two different ones. So if we go back here, we got 2 minutes to finish this one up. That's fine. All right, so if I use law of sines on this one, and I have angle side-side, so I got to be a little careful. If I use law of sines, I go sine of 62 over 15 is equal to the sine of x over 8. Now I'm trying to find the angle, so I have to use the inverse when I'm calculating here. So this is going to be 15 times the sine of x is equal to 8 times the sine of 62. And so you get the sine of x by itself, and that's equal to 8 times the sine of 62 all over 15. If you're finding an angle, you have to use the inverse sine. So I use the inverse sine of both sides. And I calculate that, and I do the inverse sine of all that, and I get what? Inverse sine of 8 sine 62. Shoot. All right, inverse sine 8 sin 62. All right, well, all you guys are leaving, okay, and that's, you have to leave, but I'll finish this up. And so, can you stop rolling the chair for a minute? It's kind of loud. Um, the thing that you got to remember is once you find this angle, you have to consider that angle and then the supplement of that angle. And so you have to look in your situation and see, bye, drive safe, is that angle going to be like an acute angle or is it going to be an obtuse angle? Which one makes more sense? And then you just have to make a judgment based on what the calculator gives you. So either it's the angle the calculator gives you or it's the supplement of that angle. All right? Bye. See you Friday. Okay. I'm going to pause this and calculate that. All right, so I'm back. So I calculated and it was 28.1 degrees or 151.9 was a supplement to that. And if you look at the picture here, obviously this is 28.1. It's an acute angle, not an obtuse angle. 151.9 is not even possible because if you added that to 62, you would get over 180 degrees, so it doesn't even work. All right, so bada bing, ciao. Be careful driving out there. We have a tsunami coming in.